One thing that might also have helped, actually, that's just come to me, the need for satellite internet. So as our internet infrastructure has got to the point where satellite internet is even viable, if you think back 20 years, that wouldn't have been a meaningful intermediate step to fund what SpaceX has done. Whereas there is now this sort of like, you don't have to get to the moon or get to Mars to be able to generate rev, basically. You can just put a bunch of satellites into the sky and charge people, whatever it is, $400 a month for satellite internet. And enough people have mobile devices and enough people connected to the internet 24/7 that, you need Wi-Fi on a plane, right? Like that is a decision thing, like a decision point that consumers will say, I'm going to fly with this carrier over that carrier because this carrier has Wi-Fi on the planes. And I'm going to go with, this boating company or this yacht because it has access to internet when I'm out at sea, and these ones don't.
Dive into the intriguing world of deep technology and its intersection with business on Technocracy. We're your hosts, Ajay and Loong. Let's explore the breakthroughs and people shaping the future of technology. Technocracy Podcast.
So actually, I do actually have a fun fact for you about Space Invaders.
Okay.
So do you know how as you play the game and you kill more Space Invaders, it speeds up?
Yeah.
That was actually not intentional. Or it was intentional, but it happened because as you kill the Space Invaders, the original game consoles were so shit that the speed up that they gained from having to process fewer invaders sped up the gameplay. And so the game getting faster was a consequence of having fewer Space Invaders to process. And they just decided that that was a good feature, right? And that became something that like modern recreations of the game had to like intentionally build in because they obviously aren't under the same constraints.
That is interesting. That's super cool. But I'm guessing they noticed that and then shipped it anyway, right? As opposed to like noticing it once they shipped it. Yeah.
There's all these cute little, when you look at OG game development, because you have these insanely shit pieces of hardware basically, and game developers had to fit so much into it. Some of the things they did were so creative and just like absolute hacks. So there's another story about, I can't remember which game it is, but they couldn't figure out why at the end of the game it would crash. So like when you completed the game, it would just shit the bed and crash. And so what they did is they made the crash screen you finished the game. Like that was the graphic they put on essentially like the 404, something went wrong. So that what would happen is you play the game, it would crash, but the crash message was, congrats, you finished the game.
That's wild. Wait, but then it would crash for no reason as well, right? So you would still see that message and it'd be confusing, right?
Yeah, if it crashed for other reasons, you'd see this, congrats, you finished the game. But I think their reasoning was that if you saw that in the middle of the game, it would be from a user experience perspective, you'd still know something was wrong versus if you got taken to a screen that said error code, blah, 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 something went wrong. It's just
more positive,
meaningful, so to speak. But because it consistently crashed at the end of the game, they were just like, screw it, that's the way we're going to go.
Yeah. Speaking of games, which I wasn't even going to talk about this, but I am curious about how the fact that like games are getting more complex over time. So think about games in the 90s, they're really simple joy controls and you had a couple of keys to press and that was it. But today it's like really intense from a controller perspective, from a combo perspective. So this game came out, Dragon Ball Sparking Zero. I don't know if you've seen it, but similar to like the Budokai Tenkaichi games that used to come out in 2003, 2004 sort of era. And it just feels so much more complex than I remember. I'm pretty sure they have made the game more complex. And what I don't understand for the life of me is how kids today come in and like learn a game like this when there's like counters and counters of counters and things like this. Whereas like back in the day when we learned a game, it was like, press the A button once and, things like that. It just doesn't make sense.
Do you have insights onto how and why that is the case? That like games have games got more complicated because we've gotten more accustomed to technology and so we can deal with it, or what's that feedback loop look like?
I think this is my opinion. I think there's a few variables. One is that gamers have evolved over time. So you have gamers who've been playing for 20 years and expect something new and different and want more mechanics, and they're evolving as gamers and therefore they want mechanics to reflect that. I think the other thing is that like so many things have been done now that you kind of have to do something a little bit different just to stand out. And I think the last one would just be, like the game consoles themselves are improving, and therefore like you can do more things, which allows people to experiment with the game mechanics.
I don't think that explains like the million different game mechanics though, because the actual complexity, like the computational complexity of having a million combos and things on the screen is not really, you're not compute limited, or at least we haven't been compute limited for that for 10 years, I'd say. So there's something definitely stylistic about it. Like I certainly look at some of the I mean, okay, I'm gonna maybe show my novicehood here, but I don't know what they're called, but like these anime inspired games, like Into the Gungeon. Like one of my friends plays this game, and when I watch him, like when I just like go over to him and he's like playing it on his phone, there's just like so much going on that I can't figure out how to pay attention to it. And that's not a compute thing, right? That's not like our phones have gotten so advanced you can put more stuff on the screen. They've just decided that that's how they want the game to be. Like it's super noisy, so to speak. There's something about that style of game that appeals to some gamers.
Yeah, like it might be an attention span thing, because I've noticed that like with certain mobile games, like once you finish one particular gauge, there's another sort of mechanic for you to go through, and like you've leveled up in level 3 in this area, but then you have this like ranking system, and like you have so many things going on that like you're never bored of a particular mechanic because you always have too many things to like. There's almost resource management across like 50 different elements of the game, and I have noticed that for those mobile games like Genshin Impact and stuff, that there's like treasure chests, loot boxes, leveling up, character levels, character spells. Like there's all these different mechanics that are like woven into it.
I find that it has the opposite impact on me. Like instead of getting bored, I get kind of overwhelmed, and I'm like, I'm not going to be bothered learning all this shit, and then I just don't engage.
I'm on the same boat, so I don't play those games, and then when I play PS5 games, I play on the easiest game mode because I want to play games to relax, not to get stressed out like trying to pass this really hard level. So I just play it on the easiest level. I don't tell anyone, but now everyone knows, I guess. But
no, you've told everyone. See, I'm the opposite. I get my stress out through gaming by playing highly stressful games, because I think sometimes when you get stressed, the stress comes from this like unresolved problem. Like a problem that's held in suspense. It can't just inherently be resolved immediately, and so you're kind of stressed about it. But a game, you can kind of release that stress. You can just kill the zombies, or you can just do whatever it is that you have to do, and you get that sort of that resolution, which kind of calms me down. Not in the moment, obviously, but like when you walk away from the game, you feel like you've left it behind.
Yeah, it makes sense. All right, we're back for season 2. I think we're doing seasons. So I think we've committed to this structure, not because we've just randomly taken a break and we've decided to come back.
That's on you. That's on you.
Yeah, I've been going through some company stuff, which I think I will talk about more publicly in 2-3 months from now, once everything's sort of finalized. And I think there's a lot of lessons I want to break down as well, so we can definitely do an episode on that. So let's just treat this as season 2. We're back, and we're going to be talking about a little bit more wide spectrum stuff. So we're still going to lean towards deep tech and science, because that's where our minds tend to go. But I think we're also opening the potential to talk about business and tech as a whole, just because deep tech, at least for me, felt a little bit limiting. And there's a couple of things I want to talk about that's just like not quite super sciencey, but just businessy and cool. And so this season, or the next few episodes, is going to be a little bit more broad spectrum. So hopefully you guys enjoy that. Do you want to start with the SpaceX stuff? Because that's super interesting.
Yeah, some non-deep tech. Let's talk about SpaceX. No, I did a little bit of follow-up reading on it, because I think everyone saw the headlines, everyone saw the videos of like catching the Super Heavy booster, and it was like really, really freaking cool to watch. And I think anyone with an engineering background, even slightly, was gushing over how complex of a thing this was to achieve. I was kind of interested in two things. Like one is like, what are the complexities? Like why is this such a hard thing to do, and why has it deemed kind of not to be worth it to date? And secondly, what's the point, right? Like it's cool that we can catch a booster engine out of the sky, but why? Like, what is the actual benefit? Like, obviously there is one, because otherwise you wouldn't, a commercial entity wouldn't put all this energy into trying to figure it out. But I think that got missed in a lot of the cool like responses to these, to the achievement. It was just like, oh, we've been able to achieve this really amazing thing, and it's people were like I'm so happy that I got to see this in my lifetime. I'm like, okay, but what does this enable us to do? And so I didn't go super deep on this. I'm definitely not an aeronautics engineer. I looked at the Raptor engine stuff and I was just like, no, there's no way that I'm going to comprehend what's going on here. But really it comes down to a couple of things. So the first thing is that the catching of the super heavy booster is really just kind of phase one. The goal is to actually catch the entire Starship. And thinking is if you can't catch the booster, you're not going to be able to catch the booster and the Starship. So baby steps. So this is definitely not the end game. The point is maybe not to catch the booster. That's more or less just a test, as I understand it, to eventually make your way up to catching the entire spacecraft, which makes a bit more sense. The second thing is that I think people have probably seen all the videos of these ships landing back themselves on pads. And so one of the questions that I had seen people asking was, well, if we can already land these ships back on Earth, why do we need to catch them in midair? Right? That's objectively harder to do. What's the benefit? And really, there are two main benefits. The first is, I guess, the biggest, as far as I could understand it, which is that when you are trying to land a spacecraft on the ground, or land it anywhere really, the spacecraft itself, or the thing that is landing, has to have the landing gear on it. And you only have to read about space flight for all of 5 minutes to realize that it's a weight game, right? Everything is just about how do you shed weight off this thing, because every kilo is cost. You know, every kilo is something that could have been a payload, could have been a satellite, could have been a human. And so if you can catch this thing in midair, it doesn't need landing gear. It doesn't need something to land on. And it doesn't need all of that material and weight on the spacecraft. You can basically offset that weight and have it on the pad instead. So that's thing number one, way easier. As soon as I hear that, my thought goes to, well, why not just a giant net? Because then surely you don't even need to worry about it, right? You just let it fall, catch it in the net. It's safe, and you transport it back. And that leads us to the second reason, which is that it's about the speed of launch. So what SpaceX is trying to achieve is this minimized turnaround time, where the gap between landing the vehicle and launching it again is basically got down to, a matter of hours, where essentially all you have to do is refuel it, put the new payloads on, and then off you go again. Now, if you're landing on a net or at a landing pad out at sea, there's all this huge amount of time that it takes to go and fetch the damn thing, shuttle it back, place it onto the launching pad, and get everything prepared. But if you catch it on the launching pad, you're basically ready to go straight away. All you need to do is refuel and put the new payload on. And so you can be doing launches that have an incredibly fast turnaround time. And I think if you're really interested in putting as much satellite material in space as you can, or doing as many launches as you can into space, getting that, the number of bases that you need is suddenly far fewer, because if you want to do 10 launches in a day, you can do that off one base instead of suddenly only being able to do one launch off a base in a day. And so therefore you need 10 bases. So your sort of initial cost of capital also goes down. And yeah, I mean, that was honestly, that was the depth of my reading on the matter. I was just kind of curious as to, what is the benefit at the end of the day of being able to catch these things. And the final thing I'll say on it is why it's so hard. We've seen videos of people landing these things, and when you're watching it just does look like it's landing itself. And instead of just doing that final bit, instead it gets caught. And really the major problem that I guess, as far as I could tell, and from some of the interviews I read, that a lot of the initial engineers saw as being highly risky, is that if it goes wrong, you destroy the catching system. And now you have to rebuild. I mean, it's much bigger, as you've seen, it's a much more sophisticated piece of infrastructure. And if you're a meter off, instead of being a meter off the center of the landing pad, you're now a meter off into the tower, and you've just destroyed your tower and your ship. So the consequences of getting it wrong are much more dramatic, in the sense that if you're landing it out at sea on a big landing pad, you can be slightly off your target and everything is still going to be okay, and you've still landed successfully. When you're catching, you cannot be off target. You have to be meters on target. That's your margin of error. And then also, so the precision has to be higher, and the consequence of fucking it up is that you destroy an inherently more expensive piece of equipment, because instead of essentially booster legs now being destroyed that you have to refabricate, you've got an entire tower that needs to be rebuilt, which costs significantly more. So definitely while you're developing it, in the lead up to perfecting it, not only is perfecting it harder, but mistakes that you're making along the way are far more expensive. And so I think it's pretty phenomenal that they ultimately decided to go in that direction, and that they decided that the risk-reward trade-offs were ultimately going to be worth it. I would have loved to see the maths or the unit economics behind it. But yeah, I mean, that sort of highlights the three main things that I found interesting about that achievement.
So I only saw the clip, the 30-second clip or whatever it is. Can the chopstick arms move, or is there only a specific location and sort of snaps in place? Like,
they do move.
Coordinates
are set. They do move, but the tower itself is set, right? So you've got the tower, and that's stable, and then you've got these little chopsticks that hang off it, right? So these chopsticks can move, but if the
can they rotate 360
ship gets too close, I don't think they can rotate a full 360, because if you look at where the landing pad is relative to the arm is on the edge of it. So even if they could rotate 360, you can't launch it from the side.
Right.
So as far as the video shows, they do this, and there's a little bit of error there.
Right.
But again, you're talking meters of error, and only on one axis of freedom. Because if you on this direction you're okay, but in this direction you're hitting the tower, and the tower can't move.
Yeah, but you do have some freedom going closer or further away from the tower just because of the length of the arms, right?
Yeah, I think not much. Like when I watched the video, I was watching it and I was like, I don't know, this looks super dodgy. Like it's coming in at a bit of an angle. The flames from the booster are just like engulfing the tower.
Do you think it's difficult to stabilize it as it's coming down as well? Because if you think about it, it's like a long tower, and then you have the cylinder, for example, and then you have to basically push either side to basically keep it stable as it's coming down.
Yeah, and it only has three stabilizing engines. So
oh wow,
it doesn't have a huge amount of I wouldn't think that gives it a huge amount of mobility. Yeah. Yeah, you have to do some insanely precise calculations to get this right. And I think forgetting everything else, that is part of what makes it such an impressive achievement, right? Is the level of precision of the calculations required to do this, and the understanding of the aeronautics is just insane.
Is there anyone else working on capturing spacecrafts again besides SpaceX? Do you know?
So as far as I can tell, Blue Origin is working on landing. So I think that's basically where everyone else is at. So everyone else has realized that, okay, landing the gear is a good idea. And they haven't really successfully demonstrated that yet, let alone catching it. So you have to land it before you can catch it. If you can't land, you can't catch. Because again, I think the thinking for SpaceX was that let's perfect landing, which they've kind of done. And that's where you get all of this information about how do you stabilize a rocket in midair, to your point. How do you bring this fucking vertical tube into a precise location? And if you're landing stuff on a pad and every single time you're getting it dead center into the center of the pad, you're now at the place where you can say, okay, let's try catching this thing. But if you move straight to catching, again, the cost of error becomes super high because you're going to risk destroying the tower. And so I think that's how they offset that risk of destroying the tower, is by just perfect the landing, get it dead on within the margin of error that you have when you're trying to catch it. And once you're consistently doing that 99% of the time, now you can take that next step. And as far as I can tell, all the other space, private space enterprises, are still figuring out how to land in the first place. So SpaceX is, years and years ahead.
So this might be a bit of a speculative question, but I'm just curious. Besides time, what do you think is the thing that's moving us forward in terms of technological progression? What's changed in the last 10 years that allows us to do this now, besides people working on it for a long period of time? Is it fuel? Is it better computing? Is it a combination of everything? Do you think there's a factor that's driving us forward?
I wouldn't underestimate. Okay, I hate Elon praising. I wouldn't underestimate one crazy guy, right? Just saying there's a bunch of stuff that we should be doing and just no one's bothered to do it. Let's just fucking do it. I wouldn't underestimate a man on a mission. I think that is a huge part of it. I would say that's probably, the big part of it. I would hazard a guess that our ability to model what's going on is much higher as well. Like our computability to model the mechanics to a level of precision that you can think about things like catching and landing is much improved. I would also hazard to guess that our materials manufacturing has gone a lot better. So in terms of actually manufacturing the thing that the ships are going to be made of, and manufacturing materials that weren't traditionally used to a level of precision that is required to fly them into space, has gotten significantly better. And I think those are the kinds of things that have made this possible in the modern era. You know, like despite having not really done much space stuff as a species in the last several decades, we've definitely gotten better at manufacturing materials. We've definitely invented new materials, new alloys, new ways of doing manufacturing to get the precision to a level that's required. But I think that the major innovations, as far as I could tell, came down to the engines and the decisions around what materials to use, like the move to stainless steel was something that was like highly criticized when they first started doing it, but now it just seems to be the thing.
Yeah, interesting. Material science makes sense.
Yeah. One thing that might also have helped, actually, that's just come to me, is the need for satellite internet. So as our internet infrastructure has gotten to the point where satellite internet is even viable, you know, if you think back 20 years, that wouldn't have been a meaningful intermediate step to fund what SpaceX has done. Whereas there is now this sort of like, you don't have to get to the moon or get to Mars to be able to generate rev, basically. You can just put a bunch of satellites into the sky and charge people, you know, whatever it is, $400 a month for satellite internet. And enough people have mobile devices and enough people connected to the internet 24/7 that, you know, like you need Wi-Fi on a plane, right? Like that is a decision thing, like a decision point that consumers will say, I'm going to fly with this carrier over that carrier because this carrier has Wi-Fi on the planes. And I'm going to go with, you know, this boating company or this yacht because it has access to internet when I'm out at sea and these ones don't. And that's something that just wouldn't have been true 10, 20 years ago, right? Like, do I need Wi-Fi on a plane? Not really. I barely have Wi-Fi all the time anyway. And because of that, demand, I think, has radically increased. And also our technical ability to beam internet down at high speed from space has improved. That's now been a meaningful intermediate step that can de-risk the enterprise.
Yeah, that's cool. I like the breakdown. Makes a lot of sense.
All conjecture. Yeah.
Based on a couple of videos we watched. Okay, I've got one thing basically. And I've got like one interesting tidbit. So I think let me start with the tidbit. Just like something random I was looking into. I don't even know if this is a segment or just like something I wanted to mention. Do you know about the regulations for speedometers in Australia? Like car speedometers?
No, very little about them. I know some about it, but not a huge amount.
So like you probably heard the fact that like, oh, your speedometer is not super accurate. It's like a little bit lower than like the speed that you're going. So you won't get caught speeding if you go a little bit above, sort of thing. I don't know if you've heard that, like, you know, other people saying that. So I decided to like look at it. Yeah. And one thing I noticed when I was driving was that my Google GPS sort of speed and my speedometer speed were different by like sometimes 4 kilometers, sometimes 6 kilometers. Like there was a consistent difference between them, ranging between those two numbers. So I just looked it up. I was curious, like,
and which was it always like? Was one always higher?
Yeah, my speedometer was always higher than my speedometer reading was higher than my Google reading, and I thought, okay, well, why should I go 101 when I can go 107 and my Google is still okay? And like I'm curious, like which one would the cop use if I was to get caught? So, you know, it's like pushing a little bit. I don't know if I should admit this on a podcast, but the regulations, so Australian design rules for vehicles manufactured after 2006, it's illegal for them to show a speed that is lower than the actual speed, which makes sense. So if you're going at 100 kilometers per hour and your speedometer says 95 kilometers per hour, that's illegal. Like you can't do that. However, there is errors, right? So there has to be some sort of upper bound. And the upper bound is actually 10% plus 4 kilometers per hour. So if your true speed is 100 kilometers per hour, your speedometer can show up to 114 kilometers per hour.
But can never show less than 100 kilometers an hour.
No, it can't. It's not allowed to. You get fined. the manufacturer.
So from the manufacturer's perspective, they've got like a 107 plus or minus 7 to play with.
Yeah, I mean it's 10% plus 4 kilometers, which I think makes sense because
so
as soon as you get to like 10 kilometers per hour,
got, yeah,
yeah. I think if they made it just 10%, then at 10 kilometers, it's really hard to like get that like bound working. But yeah.
Okay, that's
so
pretty interesting. But why is speedometers so inaccurate? Like, I mean, GPS is, as you pointed out, like actually pretty accurate at determining your speed. Why speedometers so shit? I would have thought that's just like super cheap and super accurate.
Most manufacturers have an error rate of between 2 to 6%, but 6% is still pretty large. Like you could go 106 and have a true speed of 100. I think there's a lot of different factors. So there's two types of speedometers. Like there's mechanical and electrical. Mechanical is just basically there's a tube connected to your wheel that goes to your speedometer and then it connects to a magnet and generates a little bit of current that sort of pushes the dial. And then electrical is just like there's a sensor next to the wheel that sort of detects the speed. But then you have slight changes based on like if your wheel is like very low on air, obviously the diameter decreases and therefore like your RPM to speed ratio changes, right? Because you need more RPMs to get that certain speed. So then your speedometer might not be as accurate because of that. So I think there's sort of user error from that perspective, but there's also so many other factors that could change the speed as well.
It's really interesting because like if I just like was to riff on a design for a speedometer off the top of my head, right? Electrical design, because I have no idea how an analog one would work. I would just like point a sensor at the wheel, and on the inside of the wheel, you would have at sort of like 12 o'clock on the wheel, you'd have a little wedge that's a different color. So let's say the wheel is white and you have a little wedge that's black. The reason why it's a wedge is that it gets thicker on the outside and thinner on the inside. And this you would basically track the amount of time from the last time you saw the black till the new time you saw the black. And if you taper the wedge in the right way, you would compensate for, doesn't matter where the wheel is relative to the sensor, the width is compensating for the diameter at that point in the wheel.
Yeah, but what you're thinking about is the translation between the the circumference of the wheel, like, and then the pavement, right? So like, if the diameter decreases, it's going to have to spin a lot more to like get the same distance forward, and that's how you're making the calculation for the speed, right? So,
that's true actually. But you know the pressure of the tire.
Yeah,
my car tells me the pressure of my tires.
So you have another sensor that detects the pressure of the tire and then like makes a change, but that makes it, some more chances of failure at that point because if the pressure fails,
you started to a weird. Okay, that's interesting. It's interesting that that's such a hard problem to get like a cheap, accurate speedometer.
Yeah, and I guess it's not like the biggest deal either. Like, it doesn't really change much. But like, I have been speeding a little bit more just because I'm like, okay, well, I know it's not 100 now. Like, I know it's at least 102 to 106, and so I've got a little bit more.
I wonder if that would work on a cop. Like, I feel like you should try and get pulled over and then explain this to them and see if they let you go. Yeah, it's like, so according to regulation, like, is that different in every state? Is that an Australia-wide thing or is that a New South Wales thing?
It's an Australia-wide thing. I didn't look at other countries, but this is just Australia because I was just curious.
Yeah, interesting. Yeah. That's really okay. I didn't know anything about that.
Yeah, I didn't want to create a whole segment on it because I didn't have enough. But just a fun fact for everyone listening, and I hope no one comes after me for talking about it. The big thing I wanted to talk about was Kirigami. Do you know anything about Kirigami?
Not off the top of my head. It doesn't ring any bells.
Okay, so Kirigami is sort of the lesser known cousin of origami. Origami is the art of folding paper into cool shapes, Japanese form. Kirigami is the art form of making slices into paper to create new types of shapes and patterns. So you may have seen those like cards where you like sort of flip open the card and there's like a paper 3D thing that pops out.
Oh yeah.
So that's an example of Kirigami, right? So Kirigami for the application of packaging was really interesting to me. So I went into this deep dive and like some of the research, and I found that like 3M, which is like a research company, they own Scotch tape basically. And one of the packaging things they were looking into is how to use Kirigami to save on plastics. So bubble wrap is used for most things, right? When we buy something, we get bubble wrap. It's very common. They were trying to figure out a less plastic intense way of doing that sort of same packaging. And so they came up with Kirigami packaging. So I bought some, spent about $30 on packaging, but it is what it is. So this is the paper. And I don't know how blurry it is for you, Long, but the audience might be able to see it a bit better. But you can see some cuts. You can see some cuts in the paper. And when I pull it out, it turns into this hexagonal shape. And so what it's actually doing is it's changing the orientation of the paper so that it's vertical, right? And as you know, like columns in general are much stronger if you like push down on them. Yeah. And it's cool because I think, what did they say?
If anyone wants to see this in action, go buy something from Aesop. They use this as their packaging.
Oh, cool. Okay. Or just, subscribe to our YouTube channel. I thought that's what you were going to do, but that's cool. So what they said, 3M basically said, for one
trying to get a sponsor,
paper,
AJ, come on.
one truckload of paper wrap is equivalent to about 8 to 12 truckloads of plastic wrap in its unexpanded form, which is pretty good. So you're saving on transportation costs, and you need less material in general. And then also it's self-adhering, so it actually interlocks into itself because it has these little ridges, these little bumps, so they'll catch each other. And yeah, I thought it was pretty cool. There are now a bunch of knockoffs, as you can probably tell. Like, there are heaps of companies starting to do this. So this is the Chinese version, which is not bad. It just doesn't have the same like sort of depth of the hexagons. And I think it would probably be a little bit weaker.
But there's more of them. Like, I wonder how that, is it better to have more or have deeper ones? Because at some point there's going to be a optimal sort of.
I think that if you were to pull this out and then like sort of put like like a little plate on top of it and then put some force on, I think it would actually do better under load. Under load this way.
We should do this. We should review. See how many kilos.
Okay, I just ripped this. Really
I find what interests me about this is that I've often heard that one of the most expensive parts of any good is its transport. So even if you like look at this and say, well, actually, I need twice as much of it to give me the same protection as plastic. If the transportation of the plastic protection is 12 to 1 in terms of like how many truckloads of this thing you need for the same level of protection, it doesn't actually like you have a 12 to 1 margin to work with on the cost of the actual material. So even if it's more expensive to make the paper, the vast majority of cost of these kinds of goods is in the transport. And so if you're cutting down the cost of the transport, that's actually where all the savings come from. And I find that always really interesting because at least in my day-to-day, I think that's the part that a lot of people don't think about. They just look at the end product and they say, well, how much did it cost to make this? Surely that's not worth it. And they kind of forget about the transport of the thing.
Yeah, 100%. It's just like mining and other industries where they don't really think about, okay, if you bring all this ganj material and like don't think about sorting it on the at the mine itself, then we're going to have to do 15 truckloads versus 2 truckloads, and this is going to be all this extra fuel and like labor costs involved. So yeah, I agree with that point. I do think that there is a perception that paper is going to be weaker. So I do feel that people will see both of them at the store and still buy bubble wrap because it feels more secure compared to this. It's like Velcro versus like other materials. Like people, I remember talking to someone at ResMed who does the CPAP machines that sort of go on your face, and they had a version that had Velcro on it, and they said the Velcro was fine. It like worked perfectly well, wouldn't fall off your face, but the perception to users was that it felt weaker and cheaper, and so they had to switch to like a more premium sort of strap, right? So I think in the same way, people just feel like paper might be flimsier, and I can kind of get that.
I mean, I would disagree with the premium element though, because I mean, the first thing that I thought, like, it was interesting when you were showing me this, because it, like, when I thought about opening an Aesop like package that I would buy, right, and you get all this paper packaging, I had just assumed that they were doing this because it was more premium, right? That it like felt more premium. Like, you certainly, like, plastic feels shitty and cheap, and like something that's paper feels a lot more like a lot more high end. So maybe for gift wrapping and things like that, people will use these things, and that's their entry in the market. I mean, certainly, like, from a cost perspective, I think what might end up like helping is that, at least from the business perspective, you're just going to go and think that as long as it works, then you care about the cost, right? And that's basically the only thing that you care about. So as long as businesses all start doing it, then people will kind of get used to the idea that this is a safe thing that actually does work, and it does feel more premium than plastic. It does feel less cheap.
I'm trying to figure out the pricing side of things just to give a bit more reference. And I actually agree with that point. That makes sense. I do find it a little bit more premium when I get the paper wrap. So 25 meters of bubble wrap is $12. And then what is 30 feet in meters? Jesus.
Like 10?
Okay, 9 meters. Okay, so, it is, it's like 3 times more. So $34. Yeah, three to four times more money for the same like length of bubble wrap, essentially.
Do you need the same amount? Do you need the same amount of it?
I would say so. I think bubble wrap's pretty much the same thickness as like one of these expanded.
Okay.
So I think that
so it's interesting that the 12 to 1 transport savings don't translate to a cheaper end product.
To be fair, this is me comparing like just Amazon listings, right? So like this is the consumer pricing. I have no idea what the cost of manufacture is and things like that. But I guess from a consumer perspective, when I was looking at it, like these are the pricings. This one is closer to the bubble wrap pricing though. This is about $18 versus $12. But this feels way more flimsy. Yeah. Maybe I just like the premium look of the other one. Can't tell.
Once you've got premium, you can't go back.
I mean, to be fair, I bought this for the example and then I got it and I was like, wait, this is not the one I saw. So then I had to go to search for a while to find the 3M packaging and took a little bit more to get here. But luckily you pushed back the recording time. So I had time to get this one as well.
That's exactly why I did it. You're welcome.
Yeah. I knew you knew. So what I thought about next is, okay, like you have this honeycomb structure, right? And we have honeycomb aluminium, right? So I thought, okay, like do you know how they make honeycomb aluminium?
No clue. Do they use Kirigami?
For a second I did think, I was like, oh, that makes sense. Maybe they just cut into the aluminium, like yank it out and sort of see what happens. But what I did find was essentially, let me share my screen. If you want to look at what Loong is looking at, you will have to go to YouTube. There are 2 main ways of making honeycomb metals in this case. So let's just say aluminium in this case. So the first way is essentially you have a roll, like sheets that you roll out. You then put adhesive. So these little black parts are adhesive. You then create this like Hobe block by sticking them all together. And then you yank them apart. And by yanking them apart, you create this honeycomb structure because the adhesive parts basically stick together and the ones that aren't stuck together will sort of stretch out and create this hexagonal pattern. So that's one method. The other one is you create a corrugated sheet and then sort of glue the corrugated sheets together to create, you have 2 halves of a hexagonal pattern and you sort of put them together. But I did try to figure out if they use Kirigami or could you use Kirigami to do this structure. Didn't find anything like that, but what I did find is a paper from 2020 that had a new type of honeycomb structure that used the Kirigami method of manufacture that was apparently much stronger and could withstand forces from multiple directions, which I thought was interesting, but haven't actually seen any commercial applications of it. So, if anyone's listening,
in general, what are the commercial applications of honeycomb aluminium?
So, we did speak about like aerospace, right? So aerospace is like a big area where they use honeycomb materials just because you get a lot of strength, and I don't think strength is the right word. It's like resistance to forces essentially, and like durability for very light weights essentially, right? So instead of having a thick block of steel or thick block of aluminium, you have 2 sheets and then you have honeycomb in the middle of it, right? And because you have these like almost column structures, when you like push against it, it's quite good to resist that essentially.
Yeah, that makes a lot of sense. I like that you tie this back to space.
Yeah,
you can tie this back to
the...
speedometers and Australian regulation as well.
Yeah, I don't have that, unfortunately. I just needed to say that because...
Well, so the reason why the transport costs are so high is for fuel. And the reason why, like one of the reasons why we have the large tax on fuel that we do in Australia is that's actually how we deal with our road taxes. So the thinking is that the more fuel you're spending money on, the more you're driving and the more damage you're doing to the roads, right? And it kind of compensates for weight naturally, because the heavier the truck or the heavier the vehicle, the more damage it's going to do to the road, but also the more fuel it needs to move. And so they actually bake in dealing with the damage that we do to the roads and the cost that has on society by baking that cost into fuel. And then one of their recent challenges is Australia's been trying to figure out how do you deal with the fact that all of these like long transport vehicles are going to be turning electric. And so they're not going to need fuel anymore. And you can't bake it into the price of electricity because you use electricity for so many other things. And so they're starting to come up with new regulations around speedometers and other telemetry so that they like have a certain requirement to track how much this thing is moving and how much it weighs so that they can essentially tax vehicles according to how much they're damaging the roads. And there you go. That's how I tie this back in.
That's interesting. I do like some of that stuff, but I also think that some of it is a little bit like I know that there are car companies now feeding data back to insurance companies that do things like, oh, this is an unprecedented speeding event, or like they sort of revved it a bit too hard, and they get all of those data points and they provide that to the insurance company and say like, oh yeah, charge a big premium. And I know in the States there's a bunch of people that are complaining about that practice right now. So
I don't understand complaining about that practice, right? Like
an
insurance company. No, I mean, like if you're going to drive your car a certain way, pay the premiums for driving it that way, right? I mean,
okay, how often do you drive?
How often do you rev your engine?
All the time.
No, but like in like an unprecedented revving event, right? Like if you're a careful driver, your premium should be less than if you're not a careful driver. Just suck it up. Be a careful driver.
Yeah, but like, are you technically a careful driver if you never get caught? It's like Schrodinger's cat. Like, unless they open the box, they don't know.
I've got away with like 6 hit and runs, AJ. That does not mean I'm a careful driver.
Okay, that's wild. Okay, fair enough. Yeah, I just wanted to talk about the Kirigami Honeycomb. So this is a new patent that's sort of, I guess it's 4 years old now, but I haven't seen any commercial applications of it just yet. They've created this new system. So they're still doing the cuts, just like Kirigami. So they turn it into corrugated rolls, and then they have a stamping mold to create a little bit more of a different shape on the outside. Supposedly, this has a bunch of benefits around having a more three-dimensional force profile, so you can get forces from more directions, essentially, compared to traditional honeycomb. I think there was a few other benefits. Let me pull them up. Superior energy absorption, significantly higher crushing resistance in the plane directions compared to honeycomb, and it's ideal for like high peak forces, so like if there was a crash or something like that. So I guess it could be a really good way to build into automotive, into aerospace, into anything that just might have high impacts.
Well, you actually want cars to crumple. So the reason why cars look so gnarly when they crash is that's actually by design. You actually want your cars to crumple as much as possible, because it shaves off the energy, basically. Like if your car was to not compress at all when it crashes, all that energy is just getting transferred straight through the vehicle and therefore straight through you, and it's going to melt your insides.
Yeah, which is a shame. Like it's either you or the car, essentially. That's why the crumple zones, essentially, where we've
generally picked the car, which I think is the right choice.
Yeah, cool. I think that's basically all I want to talk about. This Kirigami stuff cost me about $60. So if you're listening to this, just subscribe and we'll call it even. That's worth it to me. So
60 subscribers for $60. What's that for CAC?
That's good. Worth it. Yeah, it's a $1 CAC. I'm happy with that. That's less than our CAC at entry level, so it's worth it to me. Yeah.
Well, once we get that ASOP sponsorship, then we can monetize the hell out of our listeners.
All right, guys, thanks for listening. This is a bit of a short one, but we'll see you next week. And yeah, don't forget to like, comment, subscribe on YouTube and Spotify, because those are the main areas that we sort of check and look at. And yeah, shoot us a message if there's anything interesting.